All right. Hi, everyone. I am Kim. I'm a third year going into my fourth year grad student at Temple. And today I'm excited to show you some code using Python for analyzing fMRI data. So there are a lot of neuroimaging packages within Python, although this is kind of a more new method of analyzing fMRI data. Historically, people have used programs such as AFNI, STM, FSL are three really big names. Python has become increasingly more used recently, mostly because one, it is free and coding based, so it's very flexible with what the user needs, and it is open source, so you can collaborate across many people around the world to create the code to do what you need to be done with your data. So some of the packages currently out there are NiLearn, which is one that we will use today. And there's Brainiac, PyMVPA if you specifically want to run MVPA analyses, and there's also NiPype too, kind of an offshoot of NiLearn. So why use Python for analyzing neuroimaging data? I know, FSL has been used for quite a while. Why should we deviate from that? So Python can be really flexible. You can, especially using Jupyter Notebook, you can change code by cells instead of changing the entire script. You can see the outputs after each code cell after the code runs. So it's very user-friendly, and you can easily see if there's a bug in your chunk of code. As far as like reproducibility, it is easy to share. You can export your results as an HTML for others without needing to for them to run the code themselves. And you can very easily present data to other people, such as our workshop today. I just wrote my code in a Jupyter Notebook, and I am able to share it with you all so that you can pull up the notebook yourself and run the code. And it's pretty quick, especially for a lot of data or if you have a lot of subjects. So for our data set today, we have 4 runs of the fMRI task per subject. So you'll see in the code, we have some loops in there to be able to loop through all the subjects and then also all the run numbers. And then, of course, like I said, it is open source. It is free, although that comes with pros and cons too. Some reasons why Python might not be the best option for you. You do have to know Python at least enough to be able to script using NiLearn and also to troubleshoot your code. Obviously, we all have resources within the coding outreach group, and many of the people within COG have helped me with my code too. But it does take a little bit of tinkering with to gear the code towards your own data set. And then it is fairly new, so there will be bugs. And I've also found a little bug myself off of how I need to analyze my data. But it does take a little bit of patience and to be able to troubleshoot some issues. But I will show you some resources later on to help you beyond the coding outreach group. So just an overview of what the workshop will be like. So we are working in a Jupyter Notebook. So you will need to download all of the data from the COG GitHub. Once that is downloaded, you can open the Jupyter Notebook through Terminal. If you don't know how to do this, you can also open Jupyter Notebook through Anaconda if you have that. Everyone will help you figure that out at the workshop too. So the first thing we're going to do is create what's called a design matrix. So this design matrix accounts for each of the conditions that we have within our fMRI task across all of the runs of our task. So this design matrix will take actual timing data that comes from the task script and convert that into TRs. So TRs are the images, are the 2-second images that are taken by the scanner. So this is just needed for Nylon to create a design matrix that are indexed by TRs instead of like seconds or milliseconds. And within our design matrix, we have our 3 conditions. So participants saw a category of images called tour images. They saw room images and new images, which are all objects. And then in the design matrix, we will also include our motion regressors. So that's rotation and transformation in the X, Y, and Z plane. After we create our design matrix for each participant, we will do what are called first level analyses. So these analyses will compare the 3 conditions across all of the voxels for each single subject. So you can imagine that is a lot of t-tests. And also in this step, we will smooth our data. And then after we do the first level contrast, we will move on to group level analyses. So here we will average the activation that we find from the first level across all of our subjects to get group level beta maps. So this is where we will increase our power and see what regions are being activated when we're comparing the contrast between the conditions. So outside of COG, there are other resources that you can go to troubleshoot any kind of code. So first, the Nylon GitHub, and the same goes for any kind of package you use in Python. Go directly to the source if you're unsure what the code does or what the function does. There's also a really great tutorial on DartBrains, which Liz and Haroon covered in last summer's COG workshop for neuroimaging in Python. And then for troubleshooting, if something goes wrong or you really can't figure a bug in your code out, you can take your question to forums such as NeuroStars or Stack Overflow. And then I don't have it on this slide, but sometimes Twitter is also a great resource. Okay, so now we're going to actually run the script for the workshop. So for this, we have in-person help. So if you have any troubles running the code, something's not working, definitely reach out to us and we will try to help each other together.